Good evening, everyone. Hello. I hope my voice is clear. Hello. Is my voice clear? Okay, fine. You can unmute yourself and talk. No problem. So, yeah, uh, yesterday we completed understanding what is limits. So, now today we will discuss how to evaluate limits, right? How to evaluate limits is basically by using L'Hopital's rule. L'Hopital's rules, as I would like to say, LH rule. So for that, we would, we should know what derivatives. I hope you all have done derivatives. Like you all have done derivatives in physics, the basic formulae. Don't worry, just will also revise here. We'll also revise here. So let us start with let us start with the derivatives. So I hope you know all this. I hope you know all this formulae. So yeah, first let us say a function is represented by f of x, and you must know that its derivative is represented by f dash of x. So C means it's a constant. C means it's a constant. So derivative of constant is 0. Now, x raised to n. X raised to n. Derivative of x raised to n is n x raised to n minus 1. Next, derivative of 1 upon x raised to n is minus n upon x raised to n minus 1. And lastly, derivative of root x is 1 upon 2 root x. I hope you are all familiar with these formulae. So if you have any doubt or if you don't know the formula, just tell me so we can again go through it. Here it is trigonometric function. So in trigonometry, we have six functions: sine, cos, tan, cot, sec, and cosec. Each of the derivative are written here, which are denoted by f dash of x. So derivative of sine x is cos x. Derivative of cos x is minus sine x. Derivative of tan x is sec square x. Derivative of cosec x is minus cosec x cot x. I hope you are getting all this. If you know the formula, please let me know. Okay. And lastly, we have derivative of log, which is 1 upon x. E raised to x is e raised to x, and a raised to x is a raised to x log a. I hope you all know this formula. So if you know, there is one more thing we need to do before jumping into the LH rule. LH rule means L'Hopital rule. I like to say it as LH rule. So yeah, let be go to the next, which is the rules of derivative. So in total, we have four rules. First is addition rule, as I would like to say. Second is subtraction rule. Third is multiplication or product rule, and fourth is division rule. Now, as you can see that if a function y, or you can also say it as f of x, is addition of two functions u and v, then if like to call it, like if I need to take derivative, I will write dy by dx is equals to derivative of both the functions. So it basically means that the addition of two functions, and if we take derivative, then the derivative also gets added. So same rule is for subtraction. Here, as you can see, if two functions u and v are subtracted, then their derivative will also be subtracted. Let us take a very simple example. If I take a function y is equals to x square plus x. This is the addition. Now, if I write dy by dx, which is derivative of y with respect to x. So what is x square ka derivative? X square ka derivative is 2x. X square ka derivative is 2x. And what is x ka derivative? It is 1. So basically this plus remains as it is and same is for minus. So here also if I take a very simple example like y is equal to x minus 1. So I can write dy by dx x is equals to derivative of x which is 1 and derivative of 1 which is 0 which is equals to 1. I hope this cleared. You can basically they are very simple. Doubts, you understood all? Yes, no, no doubt. Okay, let's move forward. Next is the product rule. So as I would like to say this product rule or I as I read this product rule. So I read it in a very simple way that if y is a product of two functions, u and v, then dy by dx is u derivative of v plus v derivative of u. U derivative of v plus v derivative of u. So basically, if I take a simple example of y is equal to x into c. So let us take this as dy by d. Now it is not clear. Now it is, let me check. Now, I hope now it is clear. I guess there is some network issue, but it's fine. Now I think it will be fine. Okay, very good. Chalo. So if I write dy by dx, it will be basically we substitute this formula. So u remains same means x into derivative of sine x plus sine x into derivative of x. So as you all know, what is derivative of sine x? It is cos x plus sine x into derivative of x. What is derivative of x? It is 1. So my final answer will be x cos x plus sine x. X cos x plus sine x. I hope this is clear. And lastly, we need to know division rule, U upon V rule. So U upon V rule is very simple. It looks similar to this, but here just it is minus sign. Please note V derivative of U minus U derivative of V upon V square. What is the division rule? How do I read it? It is basically I read it that way because it helps me remember it. So if you also got some help by remembering it, then you can also remember it like that. So v derivative of u minus u derivative of v upon v square. So same if I take a simple example, y is equals to x upon sine x. So basically here u is x and sin x is v. So if I write dy over dx, that will be equal to v means sin x into derivative of u. U is 1. Derivative of u is 1 minus u x. Derivative of v. Derivative of v means derivative of sine x, and it is cos x. The whole upon v square. V square means sine square x. So if I simplify it, my final answer will be very simple. Sin x minus x cos x upon sine square x. Now, I hope this is product and division rule is clear. And if not, don't worry, we have taken some examples in the next slide. So we'll go through with it. Here is a note. Basically, if there is a constant which multiplies with a function, suppose, let's say I have y is equals to 2 into sine x. So 2 is a constant which is multiplying with the function sine x. Then while taking derivative, 2 makes no difference. Like 2 remains 2 as it is if it is multiplied. So that means if I write dy by dx here for this, I can write 2 as it is and just write the derivative of sine x, which is cos x. So basically, if 2 or any constant is in multiplication, then it makes no difference. Okay. So here, next slide, we have some examples to go through it. So you can be familiar or you can revise the derivatives again. So here, there are three examples. First one is y is equals to x raised to 3 by 2. This looks like x raised to n, the first formula we did, and these both are same. The first example is based on the sum rule and the subtraction rule, addition rule and subtraction rule. So if I write dy by dx, addition will be addition same and subtraction will be subtraction same. There is no difference in addition and subtraction. So let's see, x raised to n. X raised to n. What is the derivative of x raised to n? It is n x raised to n minus 1. In place of n, we have 3 by 2. So I will write 3 by 2 x raised to 3 by 2 minus 1 plus. What is derivative of log x? It is very simple. It is 1 upon x. And last, what is derivative of cos x? Please note, don't make a mistake here for the sign. It is very simple mistake. This minus is of this, and cos x derivative is minus sin x. So finally, we will get 3 upon 2 into x raised to 1 upon 2 plus 1 upon x, and again it will be minus minus plus sin x. I hope it is clear now. So dy by dx is this. The second example is again the example of product rule. Here e raised to x and log x are getting multiplied. So if two functions are getting multiplied, I can take any one as u and I can take the other one as v. So if I try to write dy over dx, dy over dx, then what will be dy over dx? Do you remember the formula? It was u derivative of v, u in v into derivative of u. So here u is e raised to x. What is the derivative of log x? It is 1 upon x plus v is log x. And what is the derivative of u means e raised to x? E raised to x derivative is e raised to x itself. So if I simplify this, there is no simplification needed. Like I can just write e raised to x upon x plus e raised to x into log of x. Okay, I hope it is clear now. And lastly, this example I have taken, which is a mixture of quotient या फिर division rule and addition and subtraction rule. If we solve this, then we can say that we are very familiar with derivatives. So for first, it is the division rule. So this is u upon this is v. So if you remember the division rule, it was v derivative of u minus u derivative of v upon v square. So if I write it here, if I substitute the values, I will get dy over dx equals to v, means x square minus 5 into derivative of u, which is x square plus 3 minus u, which is x square plus 3 into derivative of v, which is x square minus 5, the whole upon v square, means x square minus 5 the whole square. So if we simplify this, now here, let me change the color so you can see here and here. Which rule we will use? Here there is addition, means we'll use addition rule. Simply just derivative will get split. And here there is subtraction rule. So we can write it as x square minus 5 into here derivative of x square. Derivative of x square is 2x and derivative of 3 is 0 because it is a constant, minus x square plus 3 into derivative of x square minus 5. Again, derivative of x square is 2x and derivative of 5 is 0. The whole upon x square minus 5 the whole square. Now, if you want, you can simplify the numerator. Let's not go into algebraic simplification as we are short on time and we need to learn derivatives. So if you can simplify the numerator, you will get the answer. Can someone simplify the numerator for me and tell me what will be the answer? Anyone? Okay. Very good. Very good, Chirag. Chirang. Very good. If we simplify the numerator, we will get, I think, x square will get cancelled. Minus 5 minus 8 minus 16x. So my final answer will be minus 16x upon, there is no need to like open the denominator. We can keep it as x square minus 5 the whole square. So this helps me to know that you all know derivatives, are very familiar with this. Very good, superb. So now, next, if you know this, let's learn what is L'Hopital's rule. Let's learn what is LH rule. If you remember, when direct substitution method gives us one of the 7 indeterminate forms, then we apply LH rule, which is L'Hopital's rule. So questions where we cannot solve limit by using direct substitution method, we use L'Hopital's rule. So yeah, L'Hopital's rule says that just what I said, if limit x tends to a f of x upon g of x is an indeterminate form. Basically, indeterminate form, there are 7. It can be any indeterminate form. Then we can write the same limit as it is, but we just have to differentiate the numerator and differentiate the denominator. Differentiate the numerator and differentiate the denominator. Now, this, let me tell you, this procedure can be repeated n number of times unless my indeterminate form vanishes. This procedure can be repeated n number of times unless my indeterminate form vanishes. Means again, after this, after taking derivative for the first time, indeterminate form does not vanishes, then we can take derivative second time. So we'll see some examples where we have to do derivatives 2 times. So if it's clear, it will be more clear if we take this example here I have written. So let us check first by direct substitution method if it is indeterminate form or not. So if I use direct substitution method, I will get, this will be 3 square plus 2 into 3 minus 15 upon 3 square minus 5 into 3 plus 6, which comes to 9 plus 6. 15 minus 15, 0 upon 9 plus 6, 15 minus 15, 0. So this is the first indeterminate form, 0 upon 0. So this LH rule, L L'Hopital's rule, says that limit x tends to 3 will remain as it is, and we can differentiate the numerator, and then we can differentiate the denominator separately. So let's differentiate the numerator. In numerator, as you can see, we have plus and minus, means we'll use addition and subtraction rules. So addition and subtraction rule says that derivative of x square will be 2x plus, this is a note I gave you, 2 is a constant, so 2 will remain 2, derivative of x is 1, and derivative of 15, which is constant, it is 0 upon denominator x square, again we will get 2x minus 5 is constant, and derivative of x will be 1 plus derivative of 6 is 0. So now, after simplification, my question becomes limit x tends to 3, 2x plus 2 upon 2x minus 5. Now, let us check by direct substitution. I guess it is not an indeterminate form, and very good. I have already answered in the comment section, which is 8. So let us see. If we directly substitute x equal to 3, I will get 2 into 3 plus 2 upon 2 into 3 minus 5. So 3 to the 6 plus 2, 8 upon 6 minus 5 is 1, which is equal to 8. Super, very good. So my answer to this limit is 8. Now, if you understood this indeterminate forms, let us take some more examples. Now we have only questions left. So let us say how question comes. Next, these are two questions. Now, before proceeding, you should always like first use which method? The direct substitution method. So let's use direct substitution method here. Oh, sorry, here. And let's check if it is indeterminate or not. If we use 1 raised to 4 is 1 minus 3 into 1 square is 1 plus 2 upon 1 cube is 1 minus 5 into 1 square, which is 1 plus 3 into 1 plus 1. So numerator is 0. I can clearly see denominator is 3, 4, 5 minus 5, again 0. So it is an indeterminate form, 0 upon 0. If indeterminate form comes, we can directly differentiate numerator and then denominator. So my answer, yeah, my question will now look like limit x tends to 1 as it is. Differentiate the numerator. Here we will get subtraction and addition rules. So x raised to 4, derivative of x raised to 4 is 4x raised to 3 minus 3 will remain as it is, and we will get derivative of x square, which is 2x, and 2 ka derivative is 0 upon x cube. X cube ka derivative is 3x square minus 5 as it is, x square ka derivative 2x plus 3 as it is, x ka derivative 1 and 1 ka derivative 0. Okay, already someone said in the comment, very good, the answer. So now let us look how the limit will look after simplification. We will get 4x cube minus 6x upon square minus 10x plus 3. So if we use direct substitution method, that is substitute 1 in place of x, we will get 4 into 1 minus 6 into 1 upon 3 into 1 minus 10 into 1 plus 3. So upper 4 minus 6, which is 2 upon 3 minus 10 minus 1. 1 upon 2 or 2 upon 1? I'm getting 2 upon 1. So this will be minus minus cancel. My answer will be 2. It's 2 upon 1. Please cross check. 1 upon 2. Did I make some mistake? It is 2 upon 1, which is 2, na? Uh, Please somebody confirm. 1 by 2 or 2? 1 by 2. So did I make a mistake somewhere? 1 by 2, 1 by 2. I am getting 2. 4x cube minus 6x. Okay, it is fine. Now 3x square minus 10x plus 3. So 4 minus 6 is minus 2. 3 plus 3 is 9 minus. It is 2, not 1 by 2. See, I don't think I did a mistake. Oh, right. Denominator as minus 4. Very good. How did I write minus 1? Right, right. Okay. So denominator is minus 4. 6 minus 4 is 10. So I will get 1 upon 2. Yeah. Thank you. Silly mistake. Okay, no problem. Let's look at this. This is a very interesting example because here we will get subtraction rule, product rule, and okay, two rules, subtraction rule and product rule. So let us first check if it is 0 upon 0. So I will write 1 square minus 1 into log 1 plus log 1 minus 1 upon 1 minus 1. I hope you know the value of log 1 is 0. So 0, 0, 1 minus 1, 0 upon 0. This is 0 upon 0. So my answer will be limit x tends to 1. I will differentiate numerator and denominator separately. So let us differentiate numerator. Here it is subtraction and addition rule. So x square, derivative of x square is 2x minus. Please be careful here because here we are going to use product rule. So I hope I am directly using the product rule. If any confusion, please let me know. So this is u and this is v for the product rule. So I can write x u derivative of v, which is 1 by x plus log x into derivative of x, which is 1. So no need to write 1. Here x and x will get cancelled plus log x ka derivative is again 1 upon x minus 1 ka derivative 0 upon x minus 1. X ka derivative 1, 1 ka derivative 0. So if we differentiate 1, I think the indeterminate form is now vanished. So we can use the direct substitution method. I will get numerator 2x minus 1 minus log x as we open the bracket plus 1 upon x. And no need to write denominator because it is 1. If I substitute here, I will get 2 into 1 minus 1 minus log of 1 plus 1 upon 1. Log 1 is again 0. So 2 minus 1 plus 1. 2 minus 1 plus 1. So I'll get answer as 2. Yeah. Very good. So let us now move on to some next questions here. Okay, here it is. Again, let us check indeterminate forms first. So now I will directly check if I substitute x equal to 0, sine 0 will be 0 minus 0, x is 0 plus 0 upon 6, which is 0. So in numerator, I got 0 upon and denominator is x raised to 5, which is again 0. So I am still getting indeterminate form means I have to use LH rule. LH rule says the limit x tends to 0 remains as it is. Take the derivative of numerator. So here it is subtraction and addition rule. Sin x, derivative of sin x is cos x minus derivative of x is 1 plus here 1 upon 6 will remain as it is because it's a constant which is in multiplication. X cube, derivative of x cube is 3x square upon x raised to 5 is 5x raised to 4. Now Once we take derivative, we check by substituting. So if I again substitute 0, I will get cos 0 is 1 minus 1 plus 0 upon 0, which is again 0 upon 0 form. Means still I have an indeterminate form. Means I have to differentiate again. We can repeat the procedure unless the indeterminate form vanishes. So once again, if I take derivative of numerator and denominator, I will get derivative of cos x, which is minus sin x, minus derivative of 1, which is 0. Here, plus 3 upon 6 will remain as it is, as they are constants, and x square ka derivative is 2x upon 5x raised to 4. 5 will remain as it is, x raised to 4 ka derivative 4x raised to 3. So if I simplify this, 3 to the 6, 6, this will get all cancelled. Okay. And here we can write 20. So let us check the indeterminate form again. Minus 0, sine 0 is 0, minus 0 upon 0. So again, the indeterminate form is still there. So we need to again differentiate. So limit x tends to 0. Let's differentiate again. So here I am left with minus sin x. So minus as it is, sin x ka derivative cos x, plus here I am left with x. So x ka derivative 1 upon, this is 5 fours are 20, will remain as it is, and x cube ka derivative is 3x square. If you can see again, it is cos 0 is 1. So I will get minus 1 plus 1 upon 0, which is again 0 upon 0. So we have to repeat again. So this will be limit x tends to 0 cos x. Cos x a derivative is minus sin x, but here minus is already there. So we will get just sin x upon, here it is plus 1. 1 ka derivative is 0, so no need to write. 23 is a 60 and x square ka derivative is 2x. As you can see, we still have 0 upon 0 form. So we still need to differentiate once again. I think this is the last time. So limit x tends to 0, sin x ka derivative is cos x upon 60 into 2, 120 into x. Now finally, I think indeterminate form is Gaia. So indeterminate form is cos 0. Cos 0 is 1 upon 120 into 1, which is 1 upon 120. I hope this is the correct answer. Someone said minus 120. So I guess you made a mistake here, like from year to year. Please check. Minus cos x, it was already there. Cos x derivative is minus sin x. So that minus sin x from formula, and this minus will become plus. I hope you got it. I guess you made this mistake. Someone just said the answer, which is minus 1 upon 120. I hope you got the mistake here. So yeah, should we proceed? Okay. Here, do you know chain rule in derivatives? Because in next term we are going to need it. So if not, then we can, like, we will already be doing the all the rules in detail. Achha, someone said this answer is 0 already. Okay. So I hope you all know the chain rule in derivative. Okay. If not, just remember that derivative of cos 1 upon 0. Someone is saying 1 upon 0. Derivative of cos square x. Derivative of cos square x is minus sine 2x. I hope you are familiar with trigonometry double angle formula. Okay. So let's see. Here, I think it will be 120 only, not 120x. Previous question. Oh yeah, here, right. So this will be 120 because we took derivative of x, na? Very good. Yeah. Okay. Thanks for pointing out. So it will be 120. So answer is 1 upon 120. No issues. Now let's move here. Here, if we check the indeterminate form, I guess you have already checked, right? So this is the thing that once we go into the flow, we tend to mistake or we directly do the derivative. I guess the someone who got some answer 1 upon 0 did the same thing, because if we directly do the derivative without checking the direct substitution method, there can be a mistake here. So first, always make a rule, you check the indeterminate form by directly substitute. So if I substitute x equal to 0, I get 0 minus sine 0 upon 0 plus cos square 0. And 0 minus sine 0 is 0 upon 0 plus cos square 0. Cos 0 is 1. So I will get 1. And 0 upon 1 is not an indeterminate form. It is 0. So there is no need to use LH rule. My answer is directly 0. This is a very common mistake, and I used to do it all the times when I studied, because I did not like when I got familiar with LH rule, I avoid checking the indeterminate form. So many a times I made this mistake. So I hope you don't make, always first check indeterminate form by directly substituting. So let's move on to next. For this is the first one and this is the second one. Okay. So as you are all trying before me, I would like you all to try this also. And I will wait some 1 minute or so, because in J you get 1 minute per question. Yes. So I'll let you try the first question. If anyone got the answer of K, then said, and then I will proceed. Okay. Let's see what you'll get. I have set timer for 1 minute. Both the questions are interesting. Like, it's simple but interesting. There will be one point where you need to take care. Second will be one. Okay. Someone is Chirang is saying second is one. What about the first one? Anyone try to solve the first one? Like, I have gradually increased the difficulty level of the questions, so don't mind. 20 more seconds. The timer. Let us see. Anyone got the answer or first? Second one person got. Chirang always gives answer. Very good. Okay, 1 minute is up. I will give you extra 1 minute. So I guess you are solving it. Cos A. Okay, it will be cos A. Anyone else? Or you need some more time? First question, yeah, cos A, got it. C. Okay, two people pointed out it will be cos A. Good. So if you all are done, I would like to proceed with the first question. The first question says that there is the value of the limit is already given, that it is a sine a plus k. We just need to find k. So we need to solve this side, LHS. And to solve LHS, since it is a limit question, first we use direct substitution method. As you all have used direct substitution method, let me also use, I will get a, if I substitute x equal to a, cos a minus a cos a. upon a minus a, which is equal to 0 upon 0. If it is a 0 upon 0 form, then I guess it is indeterminate form. So we need to use LH rule. So LH rule says limit x tends to a. Now, many a times you will get confused here, as I used to get. The first term x cos a, please note that cos a is a constant. So cos A will remain cos A as it is. As we know, if a constant is in multiplication, it remains as it is. And now I have to take derivative of x, which is 1. I think some of you made this mistake because I also made a mistake. I used to make a mistake. Cos A ka derivative I used to write minus sine. But no worries. Here A is constant and cos x ka derivative is minus sine x upon x का derivative is 1 minus a का derivative is 0. So I will get cos a limit x tends to a will be cos a minus minus plus a okay wait plus a sine a upon 1 a sine x sorry a sine x a sine x upon 1. As you can see, it is not an indeterminate form, so we can write it we can substitute x equal to a. So I will get cos a plus a sine a. And what was the right hand side? What was the right hand side? It was k plus a sine a. No issues here. You can see that a sine a will get cancelled from both the sides. So my k will be equal to cos a. Very good. Those were all the students who gave the answer C. I guess everyone said the second C answer. It was right. So next, second question is a very important question where your basics of trigonometry and limits will be solved. So let us move to second question. It was asked in IIT's 90, like in the 90s, people very purana, like very old in the 90s. Recently, they don't ask such questions. Recently, they ask questions which are more solving types. Okay. So let's see here. First, when I got like don't directly differentiate because we can use LH rule only if we have indeterminate form. So if suppose I check the indeterminate form, so it will be sine infinity upon infinity. Now, we all know what infinity means, but what is the value of sine infinity? Sine infinity. Here, this is a problem. Now, let me take you what is meant by sine. If I write sine x, so what is the domain of sine x? Domain of sine x means the value of x. Domain of sine x is all real numbers. All real numbers means I can put any value of x, 0, pi by 2, 90 degree, 390 degree, and so on. And what is the range of sine x? Range of sine x is only between -1 to 1. So this means if I put any real number, I will get an output from -1 to 1. So here what I substituted? Infinity. Since I substituted infinity, I know, suppose you don't know the value of sine infinity. I agree. I also don't know. But I can definitely say it will be between -1 and 1 because that is the range of sine x. And -1 and 1 upon infinity. So if you take any value between -1 and 1, you can take any value. Let's say 0, 0.1, 0.2, any value, -0.1, -0.2. But in denominator, it is infinity. So as we all know that any non-zero, yeah, any number upon infinity is always equals to zero, because the infinity is very large number. If we divide any number by a very, 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 very large number, we will get very, very, very close to zero. And very, very, very close to zero, we write it as zero. Suppose I get 0.0000000000000 100 times zero and then 1. What is the meaning of writing so much? We will write it as zero. So -1 to 1 upon infinity, or I would like to say any number upon infinity is always zero. So this is not an indeterminate form, so no need to differentiate. So answer is zero. Someone who said 1 for the second question, I know what you did. I guess you did differentiated. Like you use the LH rule. So please avoid using LH rule here, because it is not an indeterminate form. If you use LH rule, then you might have gotten the answer as 1. I hope I am clear in this question. It was a very conceptual question which required domain and range of trigonometric functions, which is sine. So I hope this question is clear. You can say yes, no, please. Is this question clear? Yes. Okay. Very good. Chalo. So if this question is clear, like we have done many questions today, I hope you all got the gist of what is the limit and how to use LH rule. Okay. So let me take a question. Until now, we have been using 0 upon 0 form and infinity upon infinity form, right? 0 upon 0 form and infinity upon infinity form. So I guess it is now time to take other indeterminate forms. So here I have an interesting example. I'll take only one example because like it's almost time up. But let me take an example. Where should I take? Okay. Let us take this slide. And the example is, I did not plan to discuss this, but it's fine. We have time, so we can discuss something interesting. Limit x tends to 0. 1 second. Limit x tends to 0 cosec x raised to the power 1 upon log x. So if we try to check the indeterminate form, we will get cosec 0 raised to the power 1 upon log 0. I guess I'm right. So cosec 0 is 1 and log 0 is not defined. So this is basically the format 1 upon infinity. So if the format is 1 upon infinity, we can still use LH rule, but we first need to take log on both sides. Oh, I guess the format is wrong. Sorry. Cosec 0 is infinity. But sine 0 is 0, na? Cosec 0 is infinity. And this is 1 upon log 0 is infinity. So this is infinity. And just now we discussed any number upon infinity is 0. So this is the last indeterminate form, infinity raised to 0. So in such cases, we write it my limit as L and we take log on both the sides. So I will get log L is equals to limit x tends to 0 log of cosec 0, sorry, cosec x raised to 1 upon log x, right? So if you know the property of log, this log x will come forward. So I will get limit x tends to 0. I will get here log of cosec x and 1 upon log x, means basically upon log x. So now if I check the indeterminate form, I will get log of cosec 0. Cosec 0 is infinity. So log infinity upon log 0. What is log infinity? Log infinity is obviously infinity, and log 0 is also infinity, as we saw here. Log 0 was infinity. So now it is infinity upon infinity format, which is an indeterminate form. So now we can use LH rule. Basically, let me tell you one thing. LH rule can only be used if the indeterminate forms are 0 upon 0 and infinity upon infinity. Only for these it can be used. So here we got infinity upon infinity. So what do? We differentiate numerator and denominator. I hope you know the derivative of log cosec x. I don't think you all know. So let me say log cosec x is 1 upon cosec x. You don't know the chain rule, I guess. Log cosec x into minus cosec x cot x. So basically we will get minus cot x upon log x, a derivative is 1 upon x. That is limit, if I simplify x tends to 0 minus x, it will minus x will come upper, minus x into cot x. Now I don't think this is an indeterminate form, or is it an indeterminate form? Let us convert into tan x, right? So we will get limit. We are not familiar with cot x. So we'll get minus x upon tan x. Okay. So minus x upon tan x, again it is 0 upon 0 format. If it is 0 upon 0 format, we need to differentiate again. So I will get limit x tends to 0. Derivative of x is 1 and derivative of tan x is sec square x. Now I guess indeterminate form is gone. So we can substitute the value here, minus 1 upon sec square 0. And what is the value of sec 0? It is 1. So minus 1 upon 1, my answer is minus 1. I hope it is clear. I hope it is clear. Please note this is clear. If I get infinity raised to 0 form, we take log on both the sides. And please note, we got the value of log L is minus 1. So if I take anti-log, so what will the value of L? It will be e raised to minus 1, which is 1 upon e. No. Acha, you didn't understand? Okay, no issues, no issues. Don't worry. Someone who didn't understand, it's okay. We will discuss this next time because the time is already up. So don't worry. We will discuss in detail, or I will take some questions in detail in the next time for the format, like power format, where we have infinity raised to 0, 0 raised to 0 and all. Okay. Yeah. So I introduced myself in the first lecture, but I guess no one was there. So let me introduce myself. My name is Keval Parmar, and I am from Mumbai, and I teach mathematics for JEE mains. Okay, I have done my master's from IIT Kharagpur, West Bengal. So yeah, I hope it is clear, and don't worry if it is not clear. We were short on time, so I couldn't explain it properly. We will take it next time, means Monday. We'll go through some questions on Monday, and then we'll do it with like we'll continue with the next chapter, which is continuity. Okay, chalo. I hope it is clear. Thank you all. Bye bye. Take care.